All right, so we're going to look now at how do we graph these polynomial functions. And all we're going to be doing here is really just sketching it. So we already talked about what is the end behavior of these polynomials, and now we're going to try to sketch the graph a little bit more clearly, kind of fill in some of the gaps there. So in this problem right here, we have x to the fourth minus x cubed minus 2x squared plus 3. So the first thing is, from what we learned before, since my dominant term here is x to the fourth, should really know what the end behavior is going to be, right? So if we think about end behavior, I'm just going to sketch it out. I know it's going to go up and to the right and up and to the left. The middle, I'm not sure exactly what's going to happen, but I know those ends, based on that leading term, is going to go up, right, up, left. Okay, so we already talked about that. In order to fill in some of those gaps, all you're going to do is basically plug in different inputs and see what the outputs are. So let's have a repetitive task. So we do this by making a table of values. So there's our table of values, and we're going to plug in x values, and we're going to see what the y values are so that we can plot those points. So for example, if I plug in -3, what does that give me? Right? What is f of -3? So earlier in this section, we learned how to evaluate functions. At this point in time, okay, while you should always keep up on your order of operation skills and your mental multiplication and arithmetic, it's going to become way too long of a process to do that by hand. So we're going to use a calculator, and we're going to try to speed things up, and it's okay to do that in this case. So with the graphing calculator, I'm going to show you kind of both ways here. Now we certainly could just evaluate, right? I could plug in -3 into this function, and I could start evaluating by direct substitution, let's say here. So let's say -3 to the fourth minus -3, oops, screwed that up. Let me try that again. -3 to the fourth minus -3 cubed minus 2 times -3 squared plus 3. So I could basically plug in -3 into the function, and I could get, all right, so that's going to be 93. So then on my chart, I'm going to fill this in and say, all right, this is going to be 93. Even doing that, though, that's still going to be a pain to keep typing that out. Now, with your calculator, you could type in second, enter, and get the same thing, and now just type in -2, and then -1, and then, and so forth. We also can just plug in that function. So if you go to your calculator and click on the y equals button, click on that y equals, we can just type in the function completely. So that's what we're going to do here. We're going to type in x to the fourth. The x button is right here next to the alpha. X to the fourth minus x cubed minus 2x squared plus 3. So now we could actually just graph this, okay, and say, hey, behold, this is the graph. It's on my graphing calculator. We don't want to do that yet because we're still trying to do this by hand and kind of learn the characteristics of the graphs and trying to sketch them. But you can go to the table. You're going to go to the table of values here. So instead of clicking on graph, you're going to hit second graph, and you'll see your table of values here. So, and you can kind of go up and down there. And we're going to use this chart to sketch the graph. So the first thing I'm noticing is that when we try to plug in -3, we got 93. But if I look at my chart, -3 is -402. So something's wrong there. And this is going to happen. So it's good that I just did this. So go to your y equals and see if I can find my error here. I can see it right here. If I, instead of a minus here, I put a negative. So I got to put a minus there. And there's my error. So if I go back to the table, now we're good to go. So -3 is 93 now. And I can use this chart to fill in my table on this problem. So -3 goes to 93, -2 goes to 19, -1 goes to 3, 0 goes to 3, 1 goes to 1, 2 goes to 3, and 3 goes to 39. All right, so I create this table of values. Now obviously I can plug in an infinite number of values for x, but I'm just plugging in you know, a small set of numbers there just to get an idea. And so if we're just going to sketch this, we're going from -3 to +3. So on my x-axis, I'm just going to just 1, 2, 3, you know, put a few notches there because that's all we're doing in this graph. And then your y-scale is, now obviously some of these endpoints are going to be large, so we're not going to be able to necessarily graph those unless we make our scale quite big, but we're just going to keep it pretty standard for now. So we'll kind of use the same, you know, just go up by ones for the y. So we'll just put some notches in there to go up by ones and keep it pretty simple. So then we're going to graph each point. So I'm going to say, let's graph the first one, 0, 3. All right, so 0, 3 is going to be up here. And then let's graph 1, 1. Well, that's going to be down here. And if I go the next one, 2, 3, it's going to be right here again. And then 3 goes way up, right? So 3, and again, we know our end behavior is going up and to the right. So this is now where it's just going to continue to the right. 3 is way up here, and I know my graph is just going to continue that way. Now, if I start going to the left again, -1 is at 3. So -1 is at 3 here. And then -2 is off the graph, and -3 is way off the graph. And you can see that this is going to continue and increase. So this kind of follows suit that I'm going up and to the left here. I knew that from the beginning. And so this is going to be just basically increasing that way. All right, so now we basically just need to fill in the gaps here so we can connect our points up. And you might be thinking, all right, well, we could just, you know, what is this actually going to look like? It's kind of hard to know what's going to happen here. Does it go like this? And then, you know, like what's happening in between there? It's okay at this point to use our calculator to have a little guidance there. And so if we were to go back to our calculator and we were to actually graph it, you can see, okay, you know, this is what it looks like. Okay, this is basically the pattern that we're following. It goes down, it hits this point, and then it rises up again. So it's okay because you're looking at the table anyway, right? We're looking at the table of values. So naturally, you're probably going to look at the graph as well. And so we kind of want to go in between here. We want you to be able to sketch this graph, look at the leading term, understand the end behavior, and fill in the chart. But also look at your calculator to get some help along the way. So if I were to finish this graph, all right, so I'm going to sketch this. It's going to go down, and then it looked like it went up here, and then it went up again. So there's my beautiful graph there. So just sketching in between, do the best you can. We want to first use our end behavior, our dominant term there, to at least analyze what the graph is going to look like at the ends. And then we want to create our table of values, fill in some of the details there, and then connect the points up. Look at our calculator if we need a little bit more fine tuning, but try to do some of it or a lot of it without the calculator. All right, so let's do another one. And by the way, both of these problems are your homework problems. So if you're doing these problems, these are 2 of your homework questions. All right, so here's our function. We want to sketch this. Again, the biggest thing we want you to be able to do is understand the end behavior and be able to analyze this without just plugging it into the calculator and just showing us what the answer is. So the first thing I would do is say, all right, x cubed, what does that mean? Well, that means the end behavior is going to go up and to the right and down and to the left. I know it's going to look like that at the ends, and all I'm trying to do is sketch the middle portion of that as well and put together a decent looking graph. So I need to make my table of values, and I'm going to plug in all of these x values and get the y values. So I'm going to use my calculator to speed this up. I'm going to go to y equals, and I'm going to plug in the function as x cubed plus x squared plus 2x minus 1. And so we're going to fill in these details by looking at the table of values. And so here's my table of values, and now I can plug this in. -3 goes to -25. -2 goes to -9. -1 is -3. 0 goes to -1. 1 goes to 3. 2 goes to 15. And 3 goes to 41. So again, I'm just going to keep the same type of scale here and just go 1, 2, 3. Let me try that again. 1, 2, 3. 1, 2, 3. And I'm really going to only kind of graph these first few numbers here. So I'm going to keep my scale kind of like it was before. Just go up by ones. Keep it pretty simple. And start graphing. So 0 goes to -1. So I'm going to plot that point. And then if I plug in x equals 1, I get 3. So that's going to be up here. And then let's go over here now. -1 goes to 3. So -1 goes to 3. And then again, my, oops, screwed up on that. -1 goes to -3. -1 goes down here, right? And then you can see as I plug in -2 and -3, this is just happening. It's just going to go down and to the left. It's just going to decrease. And then over here as well, as I plug in x equals 2 and 3, it's just increasing a lot. So I know, again, that this is going to go up and to the right. This is going to go down and to the left. In between here, I'm not so sure. What we could do is we could plug in more points. We could plug in like decimals and really try to fine tune this, or we just look at the calculator and just get an idea of what the graph is looking like. And you can see it pretty much just kind of slopes off like that. So then I just do the best I can, and I sketch that. Ooh, that was pretty bad, but do a better job than I did there. But there's my sketch and my graph, and that's how you have to do those problems. So it's kind of a hybrid approach of looking at the polynomial, understanding, and at least predicting what is the end behavior, and then making a table of values, filling in some of that table, doing some of the points by hand, but also looking at your calculator to speed up the process and get a better looking sketch if you can too.